Hello everyone. This video is dedicated to proving the power of a point, which is a ancient and well-known property. And what it basically states is that if you have a point outside of a circle and it touches, its tangent to the circle at some point, and let's say the length of it is the distance from the point to the point at which its tangent is A, and you have another line that goes from that point and it cuts through the circle, and you have the segments B and C. What it basically says is the following. We'll be proving this. So the first case is where the second line that isn't tangent runs through the center of the circle. In which case, what we can do is we can draw a line going from the point of tangency to the center. And we form a right triangle. So what we have here is, if we're using our previous notation, we have that this is A, this is B. The entire length was C. This part will just be C over 2. So this isn't too bad. Okay, so there's that. And this part is also C over 2. So this part also will be C over 2 since it's equal to the radius. So what we essentially have is that B plus C over 2. B plus C over 2 squared by the Pythagorean theorem equals A squared plus C over 2 squared. No problem. If we FOIL this out, if you FOIL this, if you do the math, you'll get the A squared is equal to B squared plus BC, B times C, which is also equal to B times B plus C. And so we're proven in this first case. So that's the first case, and we'll use this for the second case where it doesn't go through the center. I have drawn out a diagram for our convenience. We're considering the first case where it goes through the center, and the second case where it goes off to the side and makes a chord that's not a diameter. So what's going to happen is that if you look at this chord, which has length C, if you go from the center and draw a line D that's perpendicular, because you can draw R and R here, it's going to be a bisector. And so this is all diagrammed out pretty well. So what we know by the Pythagorean theorem is that A squared equals L squared minus R squared. So we know this. Now what we want to do is look at L squared. So we know that L squared by the Pythagorean theorem is B plus C over 2 squared. Plus D squared. And what we know about D squared, also by the Pythagorean theorem, is that it's equal to R squared minus C over 2 squared. So this equals B plus C over 2 squared plus R squared minus C over 2 in parentheses squared. And this is equal to L squared. Subtract R squared from both sides, and by the same algebra that we did before, we get B times B plus C is equal to L squared minus R squared, which is equal to A squared, which proves that it also works in this case. Hopefully this was clear. Thank you for watching.